We got maximum and we got the minimum. So, which one is the maximum and which is the minimum? There are two turning points.
Minimum is -6.
Okay, let's write it in decimals now. Okay, so it's clear. So we have these two turning points here. We got positive square root 3 and negative 6 square root 3. What is positive square root 3? Let's just write that down. So what is the square root of 3? Rounded up to 3 decimal places. 1,732. And what is 6 times root 3? 10,392. Let's just write it in terms of decimals here. Okay. So now, the turning points, which is the maximum, which is the minimum. Since there are two turning points, all you do is you check which is the higher one, which is the lower one. We'll compare the y values. You compare the y values. Negative is in the bottom, positive on the top. So the one on the top is the maximum and the one in the bottom is the minimum. Okay. So the maximum will be this one here, which is minus 1,732 and 10,392, and this one is 1,732 and minus 10,392. Any problem here? Right. Let's sketch the graph. What about the shape of the graph? Remember, you got y is equal to ax cubed. You know it's a cubic graph. So what determines the shape?
The A value.
Now shape, I mean, is it going to look like this, where maximum first, minimum second, or is it a minimum first and maximum second? So what will determine this shape is the value of A. Is A positive number or is it a negative number?
Positive.
So for this shape, A must be greater than 0. That means it is a positive number. Then here, your A is less than 0. So go to your graph. What is the equation here? There's a J. There's A. A is the number that's multiplied, the coefficient here of x cubed. So let's compare. What do we know? We know A is equal to 1. So is 1 less than 0 or is 1 greater than 0?
Greater than 0.
1 is greater than 0. This is the graph that we're sketching. Okay. Okay, so let's label the turning points. First, I'm starting with the maximum. What is the maximum turning point? Minus 1,732 and 10,392. So let's put it here, maybe here. Minus 1,732. There's your minus 1,732. Let's put your 10,392 here. When x is minus 1,732, y is a positive 10,392. Can you see that? Here, when x is a positive 1,732, your y is a minus 10,392. So we're going down there and here. Alright, so there's your maximum and there's your minimum. So there's a maximum turning point. Here is your minimum turning point. So what do? Turning points first, Y-intercept. What was the Y-intercept of the graph?
0.
Y was 0. So you know this graph has to pass through 0 before it connects there. Okay. So it must pass down through 0 there. So you're going to go down through 0. You join it there. And the x-intercepts we do last. So here it can only go down. So you're going down there. And here it has to go up. So we know the y-intercept is 0 and one of the x-intercepts is 0. But there's two more x-intercepts. What are they? Go back. Remember, that's the first thing that we found. We got our 0. There's 3 and negative 3. So that will be minus 3 plus 3. Label your graph. Y is equal to x cubed minus 9x. Name the graph. This is a cubic function, cubic graph. Now, your turning points. It's best to label it on the turning points. Okay. Unless you indicate with a line here, but my sketch is not very clear on the board. Okay, so it's best on the turning point, label it. This is minus 1,732, 10,392. That is the maximum, and here, label it on the turning point. Positive 1,732 minus 10,392. Is there anything that we left out? Okay, they don't ask you for the point of inflection here in N3. AB is a tangent to the circle. And so there's the jerk. In the following sketch, AB is a tangent to the circle with its center at the origin. Very important here. Center at the origin. This is a tangent. So what do you know about the theory of a tangent to a circle? The tangent and the radius of the circle. The tangent touches the circle at one point. And if I draw a radius, and at that point of contact, if you measure the angle, it will be 90 degrees. So basically the tangent is perpendicular to the radius. Okay. Right, so what is the equation of the circle? Determine the equation of the circle.
A square minus y square.
Your equation in general is x minus a squared plus y minus b squared is equal to r squared. That's in general of any circle. But now you got the center. The center AB is equal to 0, 0. Center at the origin. Okay. So therefore, this becomes x minus 0 squared plus y minus 0 squared is equal to r squared. X minus 0 is what? It is x. So therefore it becomes x squared plus y squared is equal to r squared. Why? Because a and b were 0, 0. Center at the origin. Okay. Now you're lucky here in N3 we're just dealing with center at the origin. Now, what do we need in order to find the equation of the circle? We need a point that lies anywhere on the circle. Do we have a point?
Yes.
We do have a point. So, this point, what is it? It's called P, which is x4 and y3. We can substitute this point. We can substitute into the equation of the circle.
Together.
So that's going to be 4 squared plus 3 squared is equal to r squared. So 4 squared here is 16 and 3 squared, that will be 9, equal to r squared. So r squared is equal to 25. So now, what is R? R is equal to 5, this positive square root of 25, because radius is defined as the distance. Okay, so distance is always positive, so R is equal to 5 units. Determine the equation of the circle. Your R is equal to 5 units, but now the equation of the circle is R squared. Okay, while we're on this, we're just finding R, but we don't really need to write down R. So your answer now, equation of the circle, x squared plus y squared is equal to R squared, not R. Understand that?
Yes.
So therefore, x squared plus y squared is equal to, what is R squared? 25. Don't write down the square root of 25, yeah? It's just 25, that's all. Calculate the gradients of line AB. So, calculate the gradient of line AB. So now if you read the info, if you can see on the diagram and the given information, what is line AB? Line AB is a tangent to the circle.
Tangent.
Right, so in order to find the gradients, if we had 2 points, that means if I had a point here or any 2 points on the tangent, I could use the change in y divided by the change in x. y2 minus y1 divided by x2 minus x1. But we got a problem here. We do not have 2 points. Can you see that?
Yes.
We only have 1 point, which is p. So we cannot use the gradient formula, the change in y divided by the change in x. So we need to know our theory, and the theory here, that is that the tangent is perpendicular to the radius. So the tangent is perpendicular to the radius. So what does that mean now? It means that the angle, if you measure the angle at the point of contact, it will be 90 degrees. So what is your theory on perpendicular lines? We know that the gradient, if you multiply the two gradients, the result is -1. So m, let's not call it m1 now, it's the gradient of the tangent. Let's be specific now. So m, let me just put it short, m10. So m tangent times m radius is equal to -1. So there are two unknowns here, m tangent and m radius. If I can eliminate one of those unknowns, then I can find the other one. Okay, so that means, what can we find here? We can find the gradient of the radius, which you can see. What will the gradient of the radius be? It's going to be 3 over 4, but let's just work it out. Okay, so m radius. What is the formula for gradient? It is
y2
minus y1 all over
x2 minus
x2
x1.
minus x1. What are the 2 points that we are using? We will use the origin, because there's a radius there. You can see the radius starts from the origin, and we have this point P, which is x4, y3 there. We have 2 points there. Can you see that?
Yes.
So it's up to you which one you want to call x1, y1. Doesn't make a difference which way you go. Final answer will be the same. Let's call this one x1, y1, and this will be
x2
x2, y2. If you wanted to, you can call this one x2, y2, and this x1, y1. But you can't call it x1, y2. Okay, it must be x1, y1, x2, y2. So, y2 minus y1, that will be 3 minus 0. x2 minus x1, that will be 4 minus 0, which is equal to 3 over 4. So now, what can we do with this 3 over 4? We can substitute. So now, therefore, from here, from this equation here, m tangent times m radius. So that will be m tangent times m radius, which is what we just worked out now. Can you all say that? Which is 3 over 4 is equal to minus 1. So therefore, m tangent. I don't need to show, you can do this in your head. Minus 1 divided by 3 over 4. What will it be? Minus 4 over 3. That is the gradient. Did the question ask us for the gradient? Calculate the gradient of line AB. Oh, the next question is tangent. Okay. Equation. So that was the gradient. Let's find the equation. So we want to find the equation of the tangent. The tangent is just a straight line. So in other words, we are finding the equation of a straight line. So how do we find the equation of the straight line? You could use y is equal to mx plus c, that is a standard form, or you could use y minus y1 is equal to m multiplied by x minus x1. This is the point gradient form. Okay, it's up to you. You can use any one of the two, but your final answer you will write it in standard form. Let me use a point gradient form. So if I want to use this one, that is the one that I want to use. Okay, all I need is 1 point on the tangent, and I need the gradient of the tangent. Okay, so do I have a point on the tangent?
Yes.
Yes, we have a point on the tangent. So we have P. What is P? 4 is to 3. Do we have the gradient of the tangent? So m tangent is equal to 3 over 4. So if I am using this equation, I am not substituting 4, sorry, what was that? Not 3 over 4, minus 4 over 3. Looking at the wrong thing there. That is minus 4 over 3. 3 over 4 was the gradient of the radius. Now, if I am using this formula, okay, then I am not substituting for y and x. Only if I use y is equal to mx plus c, then I substitute for x, y and m. If I am using the point gradient form, I will substitute for x1, y1 and m. Okay, so therefore you will call this one x1, y1 and there's your m. So it will be y minus y1. What is y1? y1 is 3 is equal to m, which is minus 4 over 3. X minus x1. So that's x minus your x1 there, which is 4. Okay. Now it's up to you if you want to multiply out there first or cross multiply and then transpose. Doesn't make a difference. So y minus 3 is equal to minus 4 over 3 times x, that is minus 4 over 3x, then minus 4 over 3 times minus 4, that is a plus 16 over 3. So we got y is equal to minus 4 over 3x plus 16 over 3 plus 3. So that will be y is equal to minus 4 over 3x, 16 over 3 plus 3. So that is plus 9 over 3. 16 plus 9, that will be plus 25 over 3. You got that? That was the equation of the tangent. The equation of line AB is the equation of the tangent. Okay, you can see that. Determine theta. So, you can see theta on the diagram. Let me just draw it. Determine theta, that's this question there. I'm just redrawing the line. I don't need to redraw the circle. Okay, we want to find this angle. Now, this side here is the positive x-axis. So if we are measuring an angle from the positive x-axis to the straight line, what is that? What is that special name that we give to the angle? An angle measured from the positive x-axis to the line. So this is called the angle of inclination. That is called the angle of inclination. Okay. Now, how do we work out the angle of inclination? So we know that, first of all, tan of theta is equal to the gradient. Okay. We use the formula tan of theta is equal to the gradient. So we have the gradient. There is the straight line here. The straight line is the tangent. Y is equal to mx plus c there. Can you see that? So what is m here? Minus 4 over 3. We need to find out what is theta. So theta is equal to inverse tan of m. You follow?
Yes.
So, what do we know that m is equal to minus 4 over 3? So now, theta will equal to inverse tan of minus 4 over 3. There's two ways to deal with this. One, by doing it as it is. Okay, but you need to understand the result that you are getting. Okay, then there's the other way where we use 180 minus. But let's do it as it is. What does your calculator give you now? What do we get? I can't hear what you're saying, but it's right in front. Minus 53,130. 130 degrees. Now, okay, we are getting a negative angle, minus 53,130 degrees. So, negative angle is measured clockwise. A positive angle is measured anti-clockwise, that way. Okay, so this is definitely the answer that we're looking for is measured from the positive x-axis to the straight line. So when we substitute in our calculator the negative value, we are not getting theta. We are getting this angle here, which is minus 53,130 degrees. Okay. So let's call this one alpha. This is not the theta that we are looking for. Can you see that? We are getting minus 53,130. But we know that this is what? a straight line. And a straight line measures how many degrees? 180 degrees. So this angle plus theta must equal to how many degrees? 180 degrees. You follow? So what are we saying? Let's call this one alpha. Alright. So we are saying theta plus alpha is equal to 180 degrees because we decided to just use the negative. Okay. We decided to use a negative on the calculator. This is not the angle of inclination. So theta plus alpha is equal to 180 degrees. What is alpha?
126.
Oh. Theta is equal to, what will it be? 180 degrees minus 53,130, which is equal to 126,870. Okay. Now, you could have done it this way. You could have done it this way where you ignore the negative. Right, so if you want to work out theta straight and if your m is less than 0, then what you do is, all you do is you put 180 degrees minus inverse tan of positive m. Follow what I'm saying? Okay. So now, if you always include the positive, then you need to put 180 minus, considering that your gradient was given to you as negative. So that will be 180 degrees minus inverse tan of m, and you take m as positive. Okay, so that will be 4/3. So then, you're going to get the same thing, you understand that? That will be 180 degrees minus 126,870. Sorry, 180 degrees minus
53.
53,130, which is equal to 126,870. Okay. Okay, let's deal with this one now quickly. Simplify to one trig ratio of x. How do we do this? We need to know the cast diagram here. Okay, let's just draw the cast diagram quickly. So here we got 0, 90, 180, 270 and 360 degrees. That is your CAST. This is 180 minus, and this will be, this will be 90 minus. That will be 90 plus. This will be 270 minus and 270 plus. These are for co-ratios. Okay, that's for co-ratios. Then we have just x here. We got 180 minus x, 180 plus, and 360 minus. So I got the co-ratios in blue, and I got your normal ratios here in black. Okay, because the rules are different when dealing with co-ratios and your normal. Okay, sine of 360 degrees minus x. What is the process that we're going to use here? Where is 360 degrees minus x? Which quadrant?
Fourth.
There's 360 degrees minus x. The angle directs you to the quadrant. You're not reading sine and looking for s here. No, doesn't work like that. Okay, you look for the angle 360 minus x. There is your 360 minus x. So now, what are you going to determine there? Whether what you have there is sine. So, this is quadrant number 4. Is sine positive or negative in this quadrant?
Negative.
Sine is negative, but what is positive?
Cos.
C for cos and 1 divided by cos, which is sec. Remember, it's not only cos, it's cos and 1 divided by cos, the reciprocal. So cos and sec are positive. Everything else will be negative here. So that will become minus sine of x. Okay. What about sec of 360 degrees minus x? Now exactly what I was talking about.
1 over
You are at
cos.
the fourth quadrant.
Yeah.
C stands for cos or cosine. Okay. And 1 divided by cos, which is
Sec.
sec. That means cos and sec are positive. You have sec, so it will be a positive sec of x. Tan 180 degrees minus. Which quadrant is 180 degrees minus?
Second.
Here is 180 degrees minus. It is the second quadrant. And only s, what does s stand for?
Sine.
Sine and 1 divided by sine, which is cosec. Sine and cosec are positive. Do you have sine or cosec? No. That means what you have will be negative. So that will be minus tan of x. To understand this, we need to draw the graphs, which we don't have time now to sketch all the graphs here. To know why is sine positive, why is cos negative, and so on. Cosec 360 degrees minus. 360 degrees minus, which quadrant? First quadrant. Only cos and 1 divided by cos, which is sec, are positive. What do you have? Cosec. So it will be negative here. So that will be minus cosec of x. Okay. That'll follow? Okay. You will only change to co-ratios if you are using 90 minus, 90 plus, 270 minus, or 270 plus. Okay. If I have cosec of 360 of 270 plus, then it will change to sec. Alright, but